Today I'll be going through the Physics A GCSE paper 3 for Gateway Science. This was requested by one of you, so I'm just going to take you through section A to begin with. In question number 1, we are given that a 2 kilo object moves with a velocity of 40 meters per second. What is the momentum? Mass times velocity. That's 2 times 40, so D will be the answer. Now, question number 2. What is the typical diameter of an atom? The first one is quite small. In fact, that's the diameter of a nucleus. And the second one is the right answer, as these two are fairly larger. So B is the answer here. Question number 3. A liquid which has a volume of 0.01 meter cube and mass of 12 kilos. What is the density? Density is mass divided by volume, so 12 divided by 0.01, which will give me 1200, or D. Question number 4. Which of the following uses of force causes a rotation? Rotation is, in other words, moment. The first one is lowering a book vertically from a shelf. That's definitely out. Opening a door, that is definitely the answer, because when you're opening the door, you are applying a force at a certain distance from the pivot or the hinge to make it rotate, so B is the answer. Question number 5. Which of these factors affect the strength of the magnetic field around a current carrying wire? We know that force is equal to Bill, so the magnetic field strength gets affected by the force, the current, and the length. So D is the answer here. Okay, question number 6. On the moon, a mass of 10 kilo has a weight of 16 newtons. What is the gravitational field strength? We know that W is equal to M times G. Therefore, G is 16 divided by 10, or 1.6 Newton per kilo, and so A is the answer. Question number 7. A student investigates 4 different electrical components, and she plots the current versus potential difference graphs, and which one shows that for a diode? B is the answer. Okay. Question number 8. Which object has most gravitational potential energy? We know that gravitational potential energy is mass times gravity times height. So it's proportional to the mass and the height, given that gravitational field strength is constant. So 2 kilos and 2 meters of height will give me the highest gravitational potential energy, so C shall be the answer. All right. Question number 9. We are to work out the current at point P in the circuit. We know that in parallel, the current gets shared. So if the total is 10 and one of the branch is 2.5 amps, then the rest will be 7.5 amps. So C is the option. Question number 10. A student investigates cogs and gears, and we've been given that cogs A and C have 10 teeth and cog B has 20. And A is turned 5 times. How many times does cog C turn? If A is causing B to rotate, then B is going to cause C to rotate. First, we need to work out how many times B is rotating, so we can work out C. I'm going to say that TA, which is the teeth in A, times by NA, the number of times A rotates, is equal to TB times NB. This means that NB is equal to TA, which is 10, times NA, which is 5, over TB, which is 20, and that gives me 2.5 turns. Now I can use this number to work out the final answer. TB times NB is equal to TC times NC. So therefore, NC is going to be 20 times 2.5 over 10. And that gives me 5, and hence A is the correct option. All right, question number 11. We've been given two forces acting at right angles to each other. What is the magnitude of the resultant? So that's just the Pythagoras, 16 squared and 12 squared, and that will give me 20, or B. Question number 12. We have been given 4 velocity time graphs, and which graph shows a journey with a distance of 24 meters? Distance is the area under a velocity time graph. In case of A, you're going to have 2 times 12, which is 24 divided by 2, so that's definitely not the answer. But B, which is 48 divided by 2, and that is 24, so B is the right graph here. Question number 13. We've been given the electric fields around positive and negative charges. Which one is the correct diagram? Remember that the electric field lines always go from positive to negative. So this is out. This is out because this is positive and positive. And this one is definitely out. And so from positive to negative all the way around. So that's the answer. Question number 14. A skydiver falls from a plane. His parachute opens and he lands safely. Which part of the graph shows balanced forces on the skydiver? Balanced forces means constant velocity, right? So that is going to be X and Z. Question number 15. A spring stretches by 2 centimeters when a force is added. The spring constant is 60 newtons per meter. Calculate the energy stored when it's stretched. E is half kx squared. Make sure that we have converted this into meters, so 0.02 meters, and then you just stick it all in to your calculator and you will get an answer of 0.012, or A. All right, so that's question number 15 done. That's all section A done. Let's move on to section B. So in this question, we've been given that a student puts an ice into a beaker. The mass of the ice cube is 40. The ice melts. Write down the mass of the water produced. Well, of course it's going to be 40. Mass is conserved. So part I, technically it's for 2 marks. I guess we have to explain a little bit further. The mass is going to be conserved. And that is because you can't lose the number of particles. The number of particles have to remain constant. Whatever the ice was turns into water, and therefore it's going to be 40 grams. Part B, describe one difference between physical and chemical change. There are loads of differences, but I would say that, for instance, in a chemical change, the physical properties of the products change as new chemical bonds are formed. So you would end up forming new compounds, new substances. You could also say that physical changes are reversible, mostly, and chemical changes aren't. Check out the mark scheme for all the other options. Okay, let's move on to part C. A student does an experiment to find the difference between the specific heat capacities of seawater and tap water. We've been given 2 beakers, one with tap water and seawater, both with thermometers and heaters. And we've been given that there are 5 steps, and 2 of them have been written. We just need to work out the rest of them. So first things first, once you've put that water and the seawater in, record the initial temperature using a thermometer. Step 3, switch on the heaters. Step 4, record the temperature increase each minute, let's say for 10 minutes. Part II, suggest one mistake the student made when choosing their equipment. Couple of mistakes actually. Number one is that they're using two different sizes of beaker. So that means the amount might not be the same. And secondly, the heaters should be fully submerged. Okay. And thirdly, the beakers are open. Suggest two improvements to the method followed. You can say that you gotta use insulation for the beakers and fully submerge the heaters. Okay, let's move on to question number 17. A TV has the label below on it. Voltage, power, and frequency have been given to us, and we have to calculate the current given power is potential difference times current. So we know, first of all, that current is equal to power divided by voltage, and that's 65 over 230, and that will give me 0.2826086, and make sure you round it to two significant figures, and that would give you 0.28 amps of current. Part B, the TV is turned on for 30 minutes. Calculate the energy transferred by the TV. Well, we know energy is equal to power times time. And the power is 65 watts. 30 minutes must be converted into seconds. And that would give me an answer of 117,000 joules. Okay, so that is part B done. Let's move on to question number 18. A student investigates how a spring stretches when a force is added. Look at a graph of his results and calculate the spring constant of the spring. Okay, so we know that the spring constant is the gradient of the graph, or just force divided by the extension. So everything is in the right form, right unit. So it's just going to be 5 divided by 0.2, and that will give me 25 newtons per meter. Part B. A student continues to load the spring until it passes its elastic limit. Complete the force extension graph and label the elastic limit. So for this, remember that the elastic limit is where if you remove the load, it would go back to its original length. Okay, and it's simply a slightly curved area before it reaches its plastic limit, so that will be E. Okay, and that's part B done. Part C, the student puts a small load on the spring. It is in equilibrium, and we got to draw and label a free body diagram for the load at the end of the spring. So that's relatively simple again. If you have a load, it will have a weight of mg, and because the spring is in equilibrium, the backward force or the upward force will be equal in length. So I'm going to do my best to measure. In the exam, of course, I'll use a ruler and make sure the lengths are right. But over here, I'll just go by the eye. And this force will be the restoring force, or F equals K times X. So these two forces are equal and opposite. Okay, question number 19. Happy days. A student investigates the electrical characteristics of a LED, and we've been given a circuit, and the student has made two errors connecting the circuit. Identify the two errors. Well, first of all, this voltmeter over here should be connected across the diode. And secondly, the diode over here is incorrectly connected. It should be switched round. Okay. Part II, what is the purpose of the component that variable resistor? is to alter the current. Part B. The student then connects the circuit correctly. He measures the current through the LED, which is 0.03 amps, and the potential difference is 3 volts. Calculate the resistance given this formula. R is V over I, and that is 3 divided by 0.03, which gives me 100 ohms as the answer. So let's move on to part II. Calculate the charge which flows when the LED operates for 2.5 minutes. Again, we need to make sure that we convert any units, such as minutes, into seconds. And Q, as we know, is I times T. And with the current of 0.03 amps and the time of 2.5 times by 60 seconds, okay, that would be 4.5 coulombs. Part II. Calculate the energy transferred when this LED operates for 2.5 minutes. Again, energy being charge times potential difference, that will be 4.5 times by the potential difference, which is 3. So that is going to be 13.5 joules. Okie doke. Let's move on to question 20. So here we've been given that a student is investigating building model transformers in the lab. We've been given that there are 4 different transformers that the student builds with different primary and secondary coils using an input voltage of 12. The student measures the output voltage. So we are looking at the input voltage as VP, and we have to work out VS. Explain how a transformer works and if this data supports the expected output voltages. Transformers use AC supply as this causes a change in the magnetic flux across the primary coil due to the soft iron core, of course. And then this induces an alternating voltage across the secondary coil, and that's electromagnetic induction. So now, based on the number of turns in the secondary coil compared to primary, a higher potential difference is generated if NS is greater than NP, or a lower potential difference is generated where NS is less than NP. And that's called a step up or a step down transformer, respectively. In terms of the data, let's look at some numbers over here. So, firstly, we know that the formula which relates the number of turns and the voltage is NP over NS equals VP over VS. And I'm going to work out for all of them to see whether it matches these numbers given. Okay, so for example, for A, I have the numbers as, so VS is what I'm working out. So VS is going to be VP times NS over NP, and that would be 12 times 200 divided by 100. That gives me 24 volts. They get 23 volts. So it's close, but this shows that it's not 100% efficient. Energy must have been lost in this attempt A. Okay, so let's look at the next one. For B, we again know that VS is going to be 12 times 100 over 200, and that is going to give me 6 volts, which matches with this value here. And similarly for C and D, I would end up working them out, and I get 24 yet again, and 6 for D. So That just basically means that the energy is getting lost into the surroundings in the case of A and C attempts. Otherwise, the data is consistent. Part B. A student completes a project on how dynamic microphones work, and we've been given a paragraph or two, and we need to identify one of the incorrect words and write down a correct sentence to replace the mistake. A sound wave is a pressure wave. Sound wave causes areas of high and low pressures. As the diaphragm moves in and out, so does the coil. The coil is surrounded by the magnet, a resistance. Okay, so that's a mistake. It's not resistance. It should be alternating potential difference. So the corrected sentence will be then an alternating potential difference is induced. Name a device which uses this effect in reverse. That would be the loudspeaker. Question number 21. A student investigates how the angle of a ramp affects the final speed of a trolley. And we've been given that he uses light gates to record the speed of the trolley at the bottom of the ramp. And the student releases the trolley from rest at the same point on the ramp each time. Okay, so we've been given some data values in attempt 1, 2, 3 with a means as well. Plot the results on the graph and draw a line of best fit. So we've been given 2 already. With 30 degrees, we have 3.11 as the mean. So that would be somewhere here. And then with 40 degrees, it's 3.51, which would be around about here. So this looks more like a curve. So it will go something along the lines like so. Okay, moving on to part II. Describe the pattern shown by the results. Use data from the table or the graph to, well, in your answer. It's positive correlation. Well, we gotta make sure that we explain that. The more inclined the plane is, the faster the trolley moves down the plane. And the second thing is the graph is not linear, which means that the relationship is not proportional. Speed is increasing, yes, but it doesn't increase proportionally or linearly. 10 to 20 degrees, which is the angle, is doubled. The mean speed has not been doubled. Explain why the final speed changes when the angle of the ramp increases. That's because the gravitational potential energy is increasing. So the kinetic energy gained will also be increasing, as we know that GPE lost is equal to kinetic energy gained. So for a higher initial GPE, there will be a higher kinetic energy. The student made a mistake when recording one of his results. Identify the mistake and explain what he should have done. So let's go back to the table. In this 30 degrees ramp angle, he has only recorded the final speed in attempt 1 to 1 decimal place, or 2 significant figures, compared to the rest of them. So that's what I'm going to put down. He should have done it to 3 significant figures or 2 decimal places instead. The student thinks this data shows that the results are reproducible. He is not correct. Explain why. Reproducible is when you get similar results when the experiments are done by others. But in this case, it's only him doing the experiment. So that's why he's incorrect. Okay. Part B. The mean final velocity from the ramp at 40 degrees is 3.51 meters per second. The distance is 1. Acceleration of the trolleys, what we have to calculate, giving our answer to 2 decimal places. So we know v squared is equal to u squared plus 2as. Or the other way around, a is equal to v squared minus u squared over 2s, which basically is going to be 3.51 squared minus 0, because it starts from rest, squared, divided by 2 times 1, which gives me 6.16005, and to 2 decimal places it will be 6.16 meters per second squared. Alright, next part, we need to calculate the kinetic energy for the given mass of 2 kilos and a speed of 3 meters per second. Half mv squared, and that would be half times 2 times 3 squared, which gives me an answer of 9 joules. Alright, question number 22. We've been given that a student investigates 4 gases, and we've been given the pressure and the volume of each gas. 2 readings for the same mass of the same gas at a constant temperature. We can use calculations, and we know that when we are talking about constant temperature, pressure is inversely proportional to the volume. So pressure is inversely proportional to the volume, and we have to see when does pressure increase versus when does pressure decrease. When the pressure is doubling, the volume is not changing, so it cannot be C and D. So let's think about A and B. When we have a pressure of twice as much, the volume is not being halved, right? So it can't be A and B. When you have the pressure, let's say, between A and C, then the pressure is being 4 times, and over here the volume is not being quartered, so it can't be A and C either. And then between B and C, it's the obvious choice now, because that is being doubled and that is being halved. So B and C are the answers, and you can write down how I worked out between the comparison, the scale factors, but that's what I will include in my answer here. Then part B, the student investigates another gas at constant volume and explain using ideas about particles how the temperature affects the gas pressure. Pressure increases with temperature when the volume is constant, and kinetic energy of the particles increases due to increase in temperature, and more collisions take place with the container's walls, and that's how pressure increases. Part C, calculate the pressure at the bottom of a 0.5 meters tall measuring cylinder filled with a liquid where the density is this much. Well, we know that pressure in liquids is given by rho g h, where rho is the density of 1100, g is 9.81, and h is 0.5. So that gives me an answer of 5,400 pascals. In the mark scheme, they went for g being 10, so they had gotten 5,500 pascals, so that's fine too. But that's the end of the question paper. I hope you guys found this useful, and I will see you guys in the next video.